This conference will now be recorded.
As I'm telling you in every session, the content of the material, this presentation has been sourced from internet and some books also, in a good faith. We have given due credit wherever required. You people are requested not to share it on any of the uh, professional or the personal platforms. Okay, do not share with the unknown people. Also keep it with yourself. Read as much times as you want, go through the videos as much time you want. If you want to save the videos, save it for yourself, for personal use only. Okay, no social or professional platform sharing. I'm just giving a little bit of information on the DRI production also, which I have not given yesterday. We have seen that this is the trend of DRI production, that is directly reduced iron production in India. So you can see year by year it is increasing. Slightly some decrease was there in 2016, but continuously it is increasing state. India produces almost 30% of the total production worldwide of the DRI. And in 2019, India has produced 111 billion tons of crude steel. And how many tons of DRI? Almost 30 tons of DRI. So you can say around 25 to 25% of the total steel made has used the DRI iron, that is directly reduced iron, in the steel making process. And you can see other countries also, wherein China has produced 996 million tons of crude steel. We are not talking about the finished steel. This is the crude steel through the blast furnace or other techniques. And Japan has produced 99.3. So there is a vast difference between the steel manufacturing capacities in China and other countries of the world. And who are the major producers of the sponge iron, that is DRI in India? That was a question posed by one of the participants. So I have collected the information. You people can go to this website also, that is that has details of the members of this organization, that is spongeironindia.com. And there you can see various companies name who are producing directly reduced iron, that is sponge iron, and they have given through what route also, whether it is a coal based or it is a gas based, or what technology they are using, whether it is their indigenous technology. So almost all the major steel manufacturer have their own DRI plant. You can see the prominent names like Jindal Steel, JSW, okay, Tata Steel is there, Bhushan Power and Steel. So all these people have their own DRI plant also. And then again small DRI plants are there, because the small producers are producing the steel through the electric arc furnaces. तो इलेक्ट्रिक आर्क फर्नेस में भी इसका स्क्रैप के साथ में यूज होता है, that DRI. So this is the overview, because we are going through this diagram again and again. Our whole steel making is live in this diagram. So what is there? There is a iron ore going to the iron ore, and coal which is going to the DRI plant, and you are getting the directly reduced iron. And in the second route, what you have a coal which is going to the coke oven, and you are getting coke, limestone and iron ore. And these three things are going to which one? Blast furnace. And the DRI will go to the electric arc furnace along with the scrap. The material hot metal from the blast furnace will go to the basic oxygen furnace, and even basic oxygen furnace will utilize some amount of recycled steel also, and sometimes DRI will also be used in the basic oxygen furnace. So after the blast furnace, the material will go, hot metal will go to the basic oxygen furnace, and the DRI and steel scrap or alone steel scrap will go to the, where it will go? It will go to the steel refining facility. So output from basic oxygen furnace, output from electric arc furnace will go to the steel refining facilities, because you have to adjust the chemistry as per the requirement. As you are taking, for example, 72 B grade of material, then you have to adjust the chemistry according to that. That is carbon, manganese, sulfur, phosphorus within that particular limit, and silicon also. So that is why this steel refining facility will be used. Till date, we have covered this section: blast furnace, DRI, and this input. Now, today we will learn about the basic oxygen furnace. So this diagram is very important. Please go through it again and again to understand the root of steel making. Now coming to the blast furnace reactions: iron ore, limestone and coke, तीनों को फीड हो जाएगा कहां से? टॉप से फीड करेंगे, and the reaction will take place, reduction reaction will take place, and we will get iron as a form of liquid, which is called as a pig iron. Clear है यहाँ पे? What is the combustion media used here? Can anybody tell me what is the combustion area which is producing the heat? How you are getting the heat here? Voice is not clear. How you are getting that temperature, high temperature? You are getting the temperature by virtue of coke. Okay. So that burning of the coke will generate tremendous amount of heat. In this diagram, now you can see what is the temperature here, almost 1700 degrees centigrade. From here you are sending a hot blast. That's why it is a blast furnace. So you are giving an input of hot blast, and inside there are layers of iron ore plus limestone and coke. Iron ore, limestone plus coke. So one layer is of iron ore plus limestone, another layer is of coke. So this charging will be there continuously. The hot air which comes out from here is having a temperature of around 200 to 250 degree centigrade. And where it will be used, that we will also learn. What is the reaction now that is taking place here? How you are getting the iron? Because you have a ore in the form of oxide, you have a magnetite and you have a hematite. Majorly I can say. So what is hematite? Hematite is a Fe2O3. And what is magnetite? It is Fe3O4. These are the oxides of iron. So when you get the iron ore, you are getting in the form of hematite, magnetite and others also. But these are the purest of all. In India also, majority we are having the deposits of hematite and magnetite. So what are the reactions takes place? Because temperature here is a different, here it is different, and here it is different. So at different temperature, different reaction takes place. So what happens at around 450 degrees centigrade? And as I told you yesterday also, it is not that from the Fe2O3 you are directly getting the iron. You are not directly getting the iron. No, it's the stages. You are getting in steps. So what will happen first? The Fe2O3 will react with the CO. I hope my screen is visible and annotations are also visible. It will form CO2 and 2Fe3O4, that is magnetite. This will happen at around 450 degrees centigrade, that is almost in this region. Then this Fe3O4 will react again with the CO, because continuously CO you are getting towards the top. And how you are getting the CO? By this reaction. Concentrate at this reaction. This topic is little bit critical one, critical to understand also, difficult to understand also. Lot of reactions are there. It's not just the schematics now. You have to understand you are getting a hot blast. So that will have the oxygen will combine with the carbon from the coke, and it will produce what? CO2. Now CO2 is there, but again there are layers of coke. So carbon is there again. So CO2 will be reduced by the carbon to form 2CO, carbon monoxide. And this carbon monoxide will take part in the reaction. Clear? So in the first reaction, you will get hematite to magnetite. In the second reaction now, this magnetite will again react with the carbon monoxide to form again CO2 and iron oxide, that is nothing but a oostite. And now FeO again will be at 700 degrees centigrade. It will be reduced to iron by reduction process with the CO or directly by the charcoal, that is carbon, not charcoal, coke. So from the coke carbon is there, so you will get FeO plus C, again carbon monoxide plus iron. So CO will be released from here also, which takes part in the reaction here, and the CO will be generated from here also. So this is the major reaction of iron production in the blast furnace. Now what will happen to other elements? Because there are other oxide, not element, other oxides also present in the form of what we call that one, what we call this manganese oxide, silicon dioxide, or P2O5. What we call these?
Impurities.
What is the name that we used?
Gang.
Gangue material. That's the gangue material present in the iron ore. Because from where it has come, from where the manganese oxide has come, silicon dioxide has come, or P2O5 has come.
Iron ore.
It has come from the iron ore. Now this FeO plus, what will happen? This carbon, it will have iron plus carbon monoxide. Again manganese oxide plus carbon will give manganese plus CO. So this is how elemental thing has come inside the hot metal. That's why in the hot metal, please mute yourself, everybody. That's why in the hot metal, from the blast furnace, you have, apart from the iron, you have manganese, phosphorus, silicon, and obviously carbon also, because carbon will get dissolved in the iron, because when at that temperature it starts percolating here in the liquid form, it will get absorbed in the iron also. So this is how the reaction takes place. This is another schematics showing the temperature, where it is 1500 degrees centigrade, at almost at the TURs it is 2000 degrees centigrade on this portion. How the blast is going on, like this one. And then 1500 degrees centigrade, here already it starts, liquefaction starts here. It is a fluid zone actually, all is a fluid. It called cohesive zone, means it already starts lumps, or you can say fusion started here, and the different reaction, the reduction of the iron starts from this area, and this is nothing but a preheating area. This is another schematics which will show how the charging takes place as well as how the escaping gases will be used. There was one question that yes, where this blast furnace gases the output will be used, because it has CO and what is other gas? It has CO plus
Hydrogen.
hydrogen will not have here. Don't confuse with the DRI. From
Carbon
hydrogen,
dioxide.
from carbon dioxide and one more gas will be there, because you are putting the air, hot blast air will be there, so
Carbon
it will have
monoxide.
carbon monoxide definitely will be there, CO, CO2 and nitrogen, because you are putting not only oxygen, you are putting air, so air has oxygen and nitrogen. So where the nitrogen will go? So nitrogen will also escape. And apart from that gases, you will have the particulate matter also, because this during the burning process, lot of material will get, byproduct will get produced, and because of the tremendous pressure, the tuers will be around the hearth. Almost 36 tuers were there in the blast furnace BF8 at Bhilai steel plant. So it is not only the two tuers like this one, the tuers are across the circumference, across the belly of the furnace, blast furnace. So many tuers will be there, and that tremendous air pressure will go towards the exit. So from this exit, it is collected, you can see from both sides, and where it will go? It will go to the first, the filter will be there to remove the, what you have to remove? To remove the particulate matter. And after that, the hot blast air from where it is coming, you have to heat the air, because if you inside, if you put the cold air, then definitely there will be the efficiency will reduce of the blast furnace and burning will not take place. That's why you have to input the hot air. So from where the hot air will come? It will come from the hot air stores, and this gas, the output gas from the furnace, will have tremendous amount of energy still with it, because it is having carbon monoxide, so it can burn again. So this waste gas will be used to heat the gas stores, which in turn will heat the incoming air to the blast furnace. So this is how the gas is utilized. And even after this, there will be some unburned gases. So it is not directly going to the atmosphere. What is happening? It will again being used for the generation of steam, which in turn run the blowers, which force the air here, because this air is coming with a high tremendous pressure. It's the compressed air. So to the turbine which is used to, blower which is used to make this compressed air, will also utilize the remaining gas from the hot air stores. The charging, as I told, the coke, iron ore and limestone will be in a mixed condition because it acts as a flux. So it will go through the conveyor to the top. There will be two stations, one here, one here. Hoppers will be there, two hoppers will be there. So it will get delivered to these two hoppers by way of conveyor. And at the bottom, we will get molten iron and the slag separately. Slag will be floating on the top because of its low density. Okay. So what is the typical chemistry of the hot metal then? It will be having around 3.5 to 4% carbon. We have taken one typical chemistry, and it will vary. So it can have around 3.5 to 4.5% carbon, around 1 to 1.5% silicon, 1.5% manganese, 0.5% phosphorus, 0.1% sulfur, and again other elements depending on the compounds in the ore. That will be titanium, copper, sometimes tungsten, vanadium. All these impurities will be there, but in a very small amount. This is about the flue gas, which I told you that the input to the air blast will be almost 500 to 800 degrees centigrades. So the air which is coming here, it is coming at around 500 to 800 degrees centigrade, and when it is burning in contact with this one, so it is a tremendous amount of temperature will be there. So you understand. And apart from that, the blast gas furnaces, blast furnace gas will be used in the heating of or preheating of the billets also, because when we will see the rolling process, there will be a billet, continuous casting. After continuous casting, we are getting the billets, and that billet needs to be rolled. So billets will not directly going to the wire rod mill as it is. What will happen? It will be in some storage area, and again it will be fed to the walking beam furnace, where it is again heated at a particular temperature. And for that heating purpose, this blast furnace gas can also be used if it is a integrated plant. If the blast furnace and other metalworking operation like rolling mill is there in the same complex, they can transfer the gas from the blast furnace for heating purpose also. So it's any doubt in the blast furnace, we are through with the blast furnace, all the reactions, how the reactions takes place, at what temperature it takes place, all this we have seen now. So any doubt you can ask about the reactions or any of the thing related to the blast furnace, or
The
we will
flue
move to the yeah
gases that are coming out are the waste gases, right? Which is
yeah
done with this particular blast furnace and which will be reused for some other process in the same integrated plant as we discussed.
yeah. And
Okay.
even in the blast furnace itself, because even if there is no any integrated thing is there, you
Hmm.
need hot air for the blast furnace.
Right. But then the
So that
temperature for the blast furnace is more as compared to if you are saying that the flue gases are at 500 to 800 degrees Celsius, then it can be used for some other processes rather than the blast furnace, because for blast furnace you will be needing somewhere around 2000 degree. I mean the temperature will come around 2000 degree.
no, that temperature is not because of the gas, and that not because of the air. That temperature what you are getting because of the coke, burning
Okay.
of the coke.
Okay. Okay. Okay.
Coke is used as a medium for burning there. Hot
Okay.
blast is because initial burning from where it takes place because of the hot blast.
Okay. So what is the
And then
temperature at which the hot blast air will be introduced into the furnace? If we
around
can see over here,
500.
it's
Yeah,
around
here it
500.
will be around 500 to 800 degrees centigrade. From here it will be there.
Okay.
So what will happen initially when they start, because there is a charge is put up here in the different layer, right? You can see here,
Right. Hmm.
and then the burning will start from here.
Okay. 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 Fine.
And once now this charge is already there, coke is already was there. But what
Right.
happens as the burning starts? Earlier the coke was there, the bed was there.
Right.
So when you start this furnace for the first time,
Hmm.
then there will be a solid charge here, and once you start this blowing of the hot air, it will start burning the coke
Okay.
portion and the coke portion basically. And once it is
Okay.
started, then it will continuously, because it's a continuous process there is no stoppage.
Okay. Okay.
Hmm?
Got it. Yeah.
Anything about the reactions or any doubt anybody has? Because blast furnace almost last 3 days, every day there is some discussion on the blast furnace. So if you have any doubt, you can ask. Do not get confused, because we are moving very slowly one by one topic, because there are maximum chances people get confused with the DRI, blast furnace, electric arc furnace, okay, coke oven. So all gases should not mix up.
And ladle furnace is also a different type when it
Yeah,
comes
it will be
to.
next. This diagram.
Yes. Okay. Okay.
For this
Okay.
diagram, ladle furnace is a secondary steel making.
Secondary steel making, correct. Okay.
Yeah. Now we are at the only iron making, or you can say crude iron making, or crude
Right.
steel making. Next will be the primary steel making
Okay.
by way of electric arc furnace or basic oxygen furnace, and then there will be a ladle refining
Okay.
to get the desired chemistry or the heat number we get from the ladle furnace.
Okay. In the blast furnace, in the at the mid end, there is a team of engineers where they put in all the metal, and based on only the visual, you know, based only on the visual experience, they add more kind of other metals to the composition. So I think that happens at the stage of blast furnace.
No. Blast furnace, no. In the ladle furnace or the this one, your basic oxygen steel making.
Basic oxygen. Okay. Okay.
There they add, because what happens
Okay.
in the basic, we will come to know in the next slide
Okay.
how the
Okay.
basic oxygen furnace will work.
Okay.
Anybody any doubt, or we will move to the basic oxygen furnace. Now we have a crude iron, or you can say crude steel, which is called pig iron. You cannot use it directly for any application. It can be used for making the cast iron, so the billets can the small pig iron blocks can be made and supplied to the cast iron manufacturing industries also. They can utilize it. Direct application कुछ भी नहीं है इसका. Okay, so now we have to make a usable steel for various applications. You have a DRI in one hand, and now the molten metal from the blast furnace. So how that molten metal will be utilized, we will see now. So this molten metal will be used in the steel making, which is called basic oxygen steel making. I will just give you a little bit of history of that one. It was known almost in 1855 also, that if you use the oxygen instead of air for refining the pig iron, you will get better properties. Because when people use the air, what will happen? Apart from the oxygen, what is present in the air? Nitrogen. So that nitrogen will get absorbed into the metal, causing nitrogen embrittlement. Means the properties of the steel will get affected. It becomes embrittled. Means it is having the strength but not toughness. The toughness get impacted by the nitrogen, presence of nitrogen, nascent nitrogen. So in 1855 also, the Henry Bessemer, who was inventor as well as a businessman, he knows that yes, we can use oxygen. But what was the constant that time, bottleneck that time? The oxygen, industrial oxygen, pure oxygen was not available in bulk quantity and also at a cheaper rate. So it was not utilized that time. But everybody know if we use that one, it can give us high production rate, lower labor cost, as well as quality of the steel will be higher, as there is no or low nitrogen content. It took almost 90 years for Robert Durer, who initiated the development of basic oxygen process in Switzerland. Somebody of you might have heard about the LD process. It called Linz-Donawitz LD process. And a LD converter also people call it earlier. So what is that? Why that Linz-Donawitz? Because the Robert Durer in 1940, he has done some experiment in a very small 2.5 ton pot. Not very small also, it will be almost a 2.5 ton experimental thing was there, and he found that the steel made out of that using the oxygen was having better properties. So after that successful experimentation in 1952, he started he along with one company in the Austria, which is West company. They have started a 35-ton furnace. That 35-ton furnace has started at the Linz, and apart from 1 year, almost after the 1 year, they have started another furnace in the Donawitz, that in Austria, again in Austria. So because of these two successful commercial or industrial operations, the process was called as a Linz Donawitz. And now almost 50% of the steel making is made through the basic oxygen processes. So this is about the history of basic oxygen steel making process. How the basic oxygen steel making process will look. Just have a look at a picture schematic. When we say oxygen, means definitely there will be some blowing of oxygen. Okay, and there will be a hot metal. So these converters are having almost 300 tons of capacity. One ladle furnace, these converters are having up to 300 tons of capacity. Few are having 100 also, 200 also, and 300 also. And what is used to push the air? It is called lance, air lance for the blowing of the air, and that air is blown at a supersonic velocities. It is not just blowing the air. It is not just blowing the air with the fan. The air is blown at a very high velocities, supersonic velocities. So if any one of you have gone there, you can see tremendous amount of noise also. Noise like a blast when this process is this steel is processed. You can hear the noise like a blast, and that oxygen is blown for almost around 20 minutes. Temperature will go to how much degree? Almost 1200 degrees centigrade to 1600 degrees centigrade. And you will see that there is no heating media used here. You will just use the hot metal from the blast furnace.
This is hot air, ultrasonic air is hot air.
Yeah, it will be not very hot also. It just at a warm, you can say. There is no hot air requirement here as such.
So what is the basic use of this air?
The oxygen, not air. It is used oxygen to remove the impurities. Because now you have silicon is there, manganese is there, sulfur is there, phosphorus is there, and that will be in the elemental form. So how you will remove that elements now? Excess element जो हो गए उसमें, and even carbon भी जो है almost 4.5% है या 4% है. So how you will remove that one? So you have to do the oxidation now. पहले हमने क्या किया था? ओर को डिऑक्सीडाइज किया, ना, ओर को डिऑक्सीडाइज करके हमने एलिमेंट्स ले लिए आयरन, इसमें स्टील में, क्रूड आयरन में. Now because these elements are in excessive form, now what we have to do? We have to remove that. And how we will remove? We have to remove it by way of oxidation. That's why the oxygen is used here. तो क्या होगा? जो उसके अंदर आयरन ऑक्साइड तैयार, पहले तो क्या होगा कि आयरन मैक्सिमम क्वांटिटी आयरन की है, तो व्हाट विल हैपन? आयरन विल रिएक्ट विद ऑक्सीजन टू फॉर्म FeO. दिस रिएक्शन यू कैन सी. सो सबसे पहले तो ऑक्सीजन आयरन को ऑक्साइड बना देगा, तो फिर पर्पस क्या हुआ? पूरा के पूरा ऑक्सीजन, आयरन कन्वर्ट हो गया ऑक्सीजन में, आयरन ऑक्साइड में, तो वापस ओर में चले गए हम. बट विल दैट हैपन? ऐसा हो सकता है? इट विल नॉट हैपन, बिकॉज द एफिनिटी ऑफ अदर एलिमेंट्स लाइक carbon, phosphorus, manganese, sulfur, silicon towards oxygen is much more than the iron. तो पहले तो ऑक्सीजन आयरन को ऑक्साइड कर देगा वो, but because the affinity of other elements present is much more than iron, तो आयरन को अगेन रिड्यूस करना शुरू कर देंगे कौन? कार्बन, फास्फोरस, मैंगनीज, सिलिकॉन and sulfur, and then you will start getting their oxides, that is manganese oxide, sulfur dioxide, silicon oxide, है ना, phosphorus pentoxide and carbon monoxide. Got it? So now the iron will be here in the molten bath itself. It is not going to oxidize, but you will get oxides of all the other impurities. सब impurities की ये बन जाती है उसमें. एंड इसमें लाइम भी डाला जाता है बिकॉज इट विल एक्ट एज अ फ्लक्स, एंड जितनी ऑक्सीडाइज इंप्यूरिटीज है इनको सबको बाइंड करता है साथ में. तो क्या बनाएगा? कैल्शियम सिलिकेट बना देगा. तो इनके कंपाउंड्स बना के ये सबको एज अ स्लैग बना देता है. एंड ये जो जितनी भी ऑक्सीडेशन रिएक्शंस है वो है, दीज आर वेरी एक्सोथर्मिक. सो टेम्परेचर जनरेट होता है, वेरी हाई टेम्परेचर जनरेट होता है, एंड टू अवॉइड इट डैमेजिंग द लाइनिंग, ये जो हमारे ब्रिक लाइनिंग है, रिफ्रैक्टरी ब्रिक लाइनिंग, टू अवॉइड it damaging the refractory brick lining, what is being done? The metal scrap, okay, or DRI, or even some amount of ore, but which is processed ore basically, is added to the LD converter to bring down the temperature or to maintain the temperature within operable range. Clear? And now once the blowing has been done for almost around 20 minutes, depending on how much carbon you want to keep it there, and also the purification, removal of the impurities. Once it is done, there is a tap hole here. अब ये tap hole ऊपर है, how it will get removed then? Blast furnace में where it, the tapping was where? Blast furnace tapping was at the bottom, so you can easily remove the, just a minute, my Bluetooth is not working. So you can easily remove the, can people hear me?
Yes.
Yeah. So you can easily remove the, earlier you can easily remove the metal and the slag from the bottom of the blast furnace, but now the tap hole is being given at the top. So how you are going to remove the metal and the slag? How it will be done? Any guess?
By tilting?
Yes, it will be done by way of tilting. There is only one way to do that one. So you have to tilt the furnace. So this mechanism or the arrangement what you can see here, it is for the tilting. So it will be tilted like this one. Even for taking the hot metal also, for taking the hot metal also, it is being tilted. So it will get tilted and take the hot metal, and also the scrap and every for that charging also it has to be tilted, and then it is tilted to remove the hot metal collected in the ladle furnace. This is a kind of ladle transfer car. So you will remove the slag, and also you will remove the hot metal through that particular tap hole.
सर एक क्वेश्चन है सर, लाइमस्टोन का क्वांटिटी कितना रखते हैं? रेशियो मतलब कितना रखें?
ना अगेन वो डिपेंड करता है ना कितना हमारा वो निकल रहा है. तो एग्जैक्टली मैंने भी निकाला नहीं है वो, बट अराउंड 10% के आसपास रहता होगा उसमें. जितना हमारा टनेज में अगर हम बात करें तो अराउंड 10% विल बी लाइमस्टोन, दिस लाइम रिक्वायरमेंट, नॉट लाइमस्टोन, लाइम रिक्वायरमेंट। तो भी मैं एग्जैक्टली कितना
Okay.
लगता है वो निकाल के रखूंगा मैं। आई हैव नॉट इंक्लूडेड दैट
Okay.
हियर।
Yes.
So this is another schematic, you can see चार्जिंग कहाँ पे है, लेफ्ट साइड में यहाँ पर आप देख सकते हो, इट्स अ चार्जिंग फ्रॉम हियर दिस साइड, and this is a tiltable converter, so you can see one position here and another position, means this can tilt, sorry, one position from here to here it can tilt, and another position it can tilt from this side to this side to take the liquid steel. Clear है? So and whatever the again यहाँ से जो भी हुड से गैस निकलती है वो जाके जो भी उसका प्रोसेसिंग करना है दे कैन डू दैट वन। एंड ऑक्सीजन लॉन्च कहाँ पर है? फ्रॉम द सेंटर, oxygen launching will be from the center, and it is not touching the hot metal, it is away, far away, and it's a water cooled because of the high temperature, so it's a water cooled lance, copper lance. So it will take the charge from this side, and after material has been finished it will take into the ladle. Now what will happen if it is the refining has to be done in house, it will be moved through the using the this ladle car, or another way is that this ladle furnaces can be lifted by the crane and ingots can be made out of that. The ingots ingot ke mold hai. So what will happen, it will move here, the crane will lift this ladle, and from the bottom tapping the ingots hot metal will be poured into the molds, and you will get the ingots. So you will get the steel ingots. Now it can be transferred to other location also, again it is melted and then refined also, or for some application even it is refining will not be required if the chemistry which is obtained in this furnace is acceptable for that particular application, then there is no need for further refining also, the ingots can be used for further application, but it depends. Okay, so this
Do
is
we
about the
one
yeah.
question? Do we this oxygen lance that you have shown? Can we is this process also known as charging, oxygen charging through that?
Yes, yes, yeah, yeah,
Yes, sir.
because after that then there will be no any charging in the total steel making process.
Still making
So this is
process.
called the
Okay.
oxygen charge.
Okay.
So this is about the oxygen, basic oxygen steel making. Now there is another process which are not included in today's session. Tomorrow we will discuss. It is called energy optimized furnace also, EOF they call it. No? So this is energy optimized furnaces. So why that is used? Because in that case the oxygen blowing will be from the bottom side, but the whatever the flue gas is generated, they will use it to preheat the scrap, and that scrap will be then again used inside the molten metal. So in that EOF furnace around 50% of the scrap can also be used, 40%, 50% scrap can also be used, or DRI can be used up to 30%, scrap can be used 20%, like that also they can do. And because the energy requirement is lesser, it is called energy optimized furnace. Like Jaiswal Nico in Raipur, they have a energy optimized furnace, EOF they call it. So in tomorrow's session we will discuss in detail about the EOF furnace. So the primary steel making, basic oxygen steel making we have covered. Another route is of इलेक्ट्रिक आर्क फर्नेस, है ना। इलेक्ट्रिक आर्क फर्नेस का जस्ट थोड़ा सा रिव्यू कर लेंगे हम, डिटेल में कल देखेंगे। ओके, बिकॉज आई थिंक इट्स 8 o'clock नाउ। सो इलेक्ट्रिक आर्क फर्नेस में बेसिक ऑक्सीजन में किसी को इशू है, देन वी विल जस्ट हैव द इंट्रोडक्शन ऑफ द इलेक्ट्रिक आर्क फर्नेस।
No.
Any issue in the basic oxygen steel making? Why it is
सर
used in
इसमें सर
Yeah.
इसमें कार्बन कंटेंट अपन जो रहता है कार्बन का रेशियो अपन कम कर रहे हैं ना,
हाँ
कार्बन परसेंटेज कम कर रहे हैं ना,
हम्म।
तो कितना कम होगा ये मतलब वो नहीं समझ में आएगा, मतलब कितना ऑक्सीजन देंगे और कितना कार्बन कम होगा बस।
वो सब रहता है उनका जो स्टील मेकिंग की जो प्रोसेस है, दे नो दैट
हाँ,
दैट्स व्हाई दे से अराउंड 20 मिनट्स, बट डिपेंडिंग ऑन द इनिशियल चार्ज।
अच्छा
ओके, इनिशियल चार्ज कितना है, इनिशियल जो चार्ज होता है ना हॉट मेटल का, उसमें कितना कंटेंट है, उसके हिसाब से फिर वो बाकी की जो प्रोसेस है पूरी वो उसके हिसाब से एडजस्ट करते हैं,
अच्छा
है ना। हाउ मच टाइम यू हैव टू गिव, अगर 3.5% कार्बन है तो हाउ मच टाइम यू हैव टू डू दी ऑक्सीजन ब्लोइंग। इट इज नॉट दैट कि ब्लो करते जा रहे हैं,
ओके
है ना। फिर कितना स्क्रैप डालना है, स्क्रैप की भी क्वालिटी क्या रहेगी, बिकॉज इफ स्क्रैप क्वालिटी इज नॉट हैविंग सो मेनी ट्रैप एलिमेंट, then again it will have impact on the quality. So all these things they will have the process control based on that.
ओके सर
And there is a monitoring also, because the sample will be taken and they will see that yes, this is the content, the chemical composition.
ओके सर
So the basic purpose of this process is to, what is the purpose? To remove the what is the purpose of basic oxygen steel making?
To remove the carbon impurities, sir. Impurity.
Not carbon only, to remove the impurities which are in the form of, which are elemental impurities in the form of carbon, phosphorus, sulfur, manganese and silicon. Okay, and why iron is not get oxidized? Because of the, what I said, what is that? Higher
एफिनिटी
higher affinity of other elements towards oxygen than iron, है ना। तो कार्बन, phosphorus, sulfur, manganese, they are more reactive to oxygen compared to iron. So what it will do, it will remove the oxygen from the iron. So whatever the FeO is there, it will again reduce back to the iron. So now the hot metal what we have from the blast furnace has been processed in the primary steel making, basic oxygen steel making, and you will get lower amount of all these tramp element now. Sorry. Any questions? Okay, so let us discuss little bit about the electric arc furnace. Tomorrow we will discuss in brief, है ना, कि energy requirement कितना होता है, क्या करते हैं. But as the schematic, you will get some idea from this one. थोड़ा इसको enlarge करता हूँ. Yeah. So this is the electric arc furnace schematics. Electric arc furnace कहाँ पे use करेंगे हम? Where you will use? What will be the input for that one? The input will have scrap basically. Scrap को जहाँ पे हमको process करना है, that processing units will use the electric arc furnace, because जो blast furnace की basic oxygen furnace के लिए हमको क्या चाहिए? You will require molten metal. Okay, because you don't have source of energy there. वहाँ पे कोई source of energy है? No. So you cannot utilize only scrap. Means cold scrap you cannot utilize in the basic oxygen furnace because there is no heat source there. So whatever the स्क्रैप और DRI, इस रूट इसका एज अ इनपुट यूज करके जो स्टील मेकिंग होता है, दैट इज थ्रू द इलेक्ट्रिक आर्क फर्नेसेस। छोटी छोटी यूनिट जो है विच कैन नॉट अफोर्ड टू हैव द ब्लास्ट फर्नेस की जो कैपेसिटी है वो भी बहुत ज्यादा होती है प्रोडक्शन। यू कैनॉट, इफ यू डोंट हैव दैट मच subsequent process requirement, then blast furnace commissioning, erection and all this blast furnace का utilize करना not a good decision. So छोटे प्लांट जो रहते हैं TMT बार के या इवन वायर रॉड्स के, what they will do, they will install the electric arc furnaces. Secondly, electric arc furnace में as the blast furnaces, उसमें आपने एक बार शुरू कर दिया तो स्टॉपिंग, फ्रीक्वेंट स्टॉपिंग आप नहीं कर सकते, स्टार्ट स्टॉप नहीं कर सकते हो, बट इन केस ऑफ इलेक्ट्रिक आर्क फर्नेसेस इट इज पॉसिबल। इसमें एज ए इनपुट मटेरियल हम कहां से करेंगे? इट विल बी जस्ट लाइक हर जैसा रहता है वो, जस्ट इलेक्ट्रोड्स रहते हैं, ग्रेफाइट इलेक्ट्रोड्स, एंड यहाँ पर जो स्क्रैप रहता है it will have arcing here, and because of the arcing tremendous amount of heat will get generated here, and वो heat के कारण the scrap will get melted। अब ये जो scrap के साथ साथ DRI भी यूज कर सकते हैं to adjust the impurities, because DRI में ट्रैप एलिमेंट लो रहते हैं, स्क्रैप में there is, as the source of the scrap is from various industries, ऑटोमोबाइल से लेके मशीनिंग इंडस्ट्रीज, कास्टिंग इंडस्ट्रीज, वायर इंडस्ट्रीज, सभी इंडस्ट्रीज से स्क्रैप आता है। so it has varied amount of composition as well as trace tramp element, so to reduce or to adjust that one, the direct reduced iron, that is sponge iron, will also be used in the electric arc furnaces। and then again चार्जिंग इस साइड से होता है, जैसे टैपिंग जो होता है एक ही साइड से होता है, जब इसके अंदर स्लैग वगैरह बन गया है तो उसके बाद मोल्टन आयरन और स्लैग का टैपिंग अलग अलग किया जाता है, एंड देन अगेन इट विल बी टेकन इनटू द लैडल फॉर द फर्दर रिफाइनिंग। सो आउटपुट फ्रॉम द इलेक्ट्रिक फर्नेस and output from the basic oxygen furnace or ladle furnace, it will go to the ladle refining for adjusting the chemical composition, final chemical composition adjustment के लिए ये वहां पर जाता है। सो आज के लिए इलेक्ट्रिक फर्नेस का इतना ही है, टुमारो वी विल सी इन डिटेल, है ना, बिकॉज इसमें कोई रिएक्शन एज सच नहीं है, okay, because here you don't have to bring down the composition or something like that one, clear? As compared to the basic oxygen furnace, the functioning is simple, here as such no reactions taking place, वहां पर पूरी refining reaction takes place करती है, यहाँ पर नहीं है because you have a lesser amount of tramp element।
यहाँ पे impurities तो रहेगा ना इनका स्क्रैप के साथ?
स्क्रैप में नहीं ना, स्क्रैप अल्टीमेटली आता कहाँ से? स्क्रैप इज बेसिकली योर फिनिश प्रोडक्ट ओनली ना,
बट उसके साथ मड ऑयल ये सब जो रहेगा
स्लैग में चला ही जाता है ना, फॉर दैट यू डोंट रिक्वायर एनी रिफाइनिंग प्रोसेस ना, एलिमेंटल नहीं ना, एलिमेंटल इंप्योरिटीज एज सच नहीं रहती ना इसमें, जैसे
तो इसमें कोई एडिशन जरूरत नहीं होता, लाइम बा
नहीं, इसमें स्लैग फॉर्मेशन के लिए रहेगा ना, स्लैग फॉर्मेशन के आपको लाइम डालना ही पड़ता है इसमें, बिकॉज बाकी जो इंप्योरिटीज रहती है उसको स्लैग फॉर्मेशन के लिए स्लैग फॉर्म होता ही है इसके ऊपर,
तो फ्लोट हो जाए तो फ्लोट कर,
या जो दिख रहा है ऊपर ये हमारा स्लैग ही है यहाँ पर।
अच्छा,
बट इसमें जैसे बेसिक ऑक्सीजन फर्नेस में यू हैव टू रिड्यूस द कार्बन टू दैट एक्सटेंट, बिकॉज जो स्टील स्क्रैप आएगा उसमें उसके अंदर आपको 4% तो कभी दिखेगा ही नहीं कार्बन, बिकॉज स्टील इज अप टू 2% कार्बन ओनली। तो जो भी आप ऑटोमोबाइल इंडस्ट्री में यूज करो या इवन जैसे फॉर एग्जांपल वायर इंडस्ट्री का स्क्रैप जो जाता है, व्हाट इट हैज, it has a varied amount of carbon only and varied amount of other elements, बट उसमें फॉस्फोरस 1% थोड़ी है, मैग्नीज 1.5% थोड़ी है, दैट इज ऑलरेडी अ फिनिश प्रोडक्ट, है ना, बट स्क्रैप फ्रॉम द इंडस्ट्री, अनयूजेबल।
तो यहाँ पे कार्बन इंक्रीज करने के लिए फिर कोक वगैरह यूज करना पड़ता है?
यहाँ पे नहीं, कोक नहीं करते, वो ग्रेफाइट से ही करते हैं। और बाद में लैडल रिफाइनिंग है ना अपना, लैडल रिफाइनिंग प्रोसेस में हम पूरा देखेंगे कि हाउ दे ऐड फेरो मैग्नीज, फेरो सिलिकॉन, क्योंकि आपने मैग्नीज वगैरह यहाँ तो हटा दिया था जो बेसिक ऑक्सीजन फर्नेस में, बट हाउ यू विल एडजस्ट, बिकॉज मैग्नीज इज रिक्वायर्ड। और इफ यू आर गोइंग टू मेक द स्टेनलेस स्टील, हाउ यू विल मेक द स्टेनलेस स्टील, तो आपको फिर वो फेरोक्रोम डालना पड़ता है, तो क्रोमियम अलॉयज डालते हैं इन द मिक्स, आयरन और क्रोमियम
स्टील
का
का
अलॉय रहता है।
ग्रेडेशन के लिए वो एडिशन करना पड़ता है अलग अलग?
Yes, that will be done in the ladle refining stage.
ओके ओके।
प्लेन कार्बन में उतना ज्यादा नहीं ऐड करना पड़ता है, बट वेयर एज स्टेनलेस स्टील, वेयर द निकेल, क्रोमियम, है ना, ऑल दीज एलिमेंट्स आर इन अ वेरी हाई परसेंटेज, सो देयर फेरोक्रोम विच आयरन और वो पर्टिकुलर अलॉइंग एलिमेंट का अलॉय रहता है। सो इफ यू वांट टू ऐड द क्रोमियम, जैसे स्टेनलेस स्टील में 14%, 12% यहाँ तक रहता है ना, जैसे जो 15 mm CR5 मटेरियल जो रहता है, तो मैग्नीज उसके अंदर 15% रहता है, जो रेल रोड में यूज होता है अपना, तो दैट इज हैविंग 15% मैग्नीज, तो 15% मैग्नीज कहाँ से आएगा,
वो ऐड करना पड़ेगा उसमें।
that will be added in the ladle refining furnace, so there the final chemistry will be adjusted। टूल स्टील है तो वैनेडियम, टंगस्टन, ये सब मटेरियल डालना पड़ेगा उसमें, बट maximum discussion will be stick to the plain carbon steel, how the chemistry is adjusted, and उसमें बेसिकली हमको मैग्नीज ही डालना है, बाकी सल्फर फास्फोरस द लोअर द बेटर, जितना कम होगा उतना अच्छा है।
राइट। यहाँ से बेसिकली रॉ आयरन को निकाल लेता है, देन वहाँ पे क्वालिटी ऑफ स्टील जैसा है अकॉर्डिंगली उसमें ऐड करते हैं जो जो
इसमें आपको ऑलरेडी इट इज बेसिकली अ स्टील नाउ, यहाँ से जो निकलता है ना, इट इज स्टील बिकॉज इट विल हैव लेस देन 2% ऑफ कार्बन।
ओके ओके
ओके, whereas the जो पिग आयरन था हमारा फ्रॉम द ब्लास्ट फर्नेस, इट इज हैविंग कार्बन राइट फ्रॉम 3.5% to 4.5%, so that is not a steel। so इलेक्ट्रिक आर्क फर्नेस से जो निकलता है, यू कैन यूज फॉर सम अदर एप्लीकेशन आल्सो वेयर द कंपोजिशनल रिक्वायरमेंट आर नॉट दैट हाई, उसमें आप डायरेक्ट भी यूज कर सकते हैं। अगर आपने वो अचीव कर लिया इसमें क्रैप, अगर आपको पता है इट इज हैविंग दैट पर्टिकुलर केमिस्ट्री,
रेगुलर स्टील में जैसे एंगल चैनल सब बनता है तो उसमें यूज हो ही जाता है, तो 0.23% इतना ही लगता है।
It can be used. It is not that ladle refining will be required every time. It will be required for the cases where the
special steel, special।
जैसे हमारा प्लेन कार्बन स्टील भी जो है, because it is used for the subsequent processing, so it is a special basically, so for that particularly refining will be there, or where again oxygen content lower requirement is there, तो उसमें फिर vacuum degassing process होता है, VD process जिसको बोलते हैं, so the process is where your nitrogen content will be lowered, oxygen content will be lowered, उस केस में वो रिफाइनिंग करते हैं। कुछ स्पेशल केस में there will be multiple refining processes also, and it will not be, you will not get it in single processing, so you have to do multiple processing also।
okay।
ठीक है, so tomorrow we will study in detail about the electric arc furnace and the energy optimizing furnace as well as ladle refining, क्योंकि इलेक्ट्रिक आर्क फर्नेस में कोई रिएक्शन का नहीं है, so it will be very quick and we will go through the energy optimizing furnace also and ladle refining का review। so जो हमारा स्टील मेकिंग चैप्टर है, it will be almost finished, and then there is a continuous casting basically wherein the billets are formed, there also it's just like pouring, जो भी हमारे यहाँ से हॉट मेटल मिलता है, it is taken in the ladle, जैसे यहाँ पर दिख रहा है आपको, this is on the left side continuous casting process, it will be similar whether you are getting it through the electric arc furnace or if you are getting it through the basic oxygen LD converter or basic oxygen steel making process। लैडल को इसमें ये लिया जाता है मटेरियल,
बॉटम टैपिंग होता है इसमें। सो क्या करते हैं, टन डिश जो रहती है इसमें ये हॉट मेटल पोर किया जाता है, एंड आफ्टर दैट देयर इज अ कंटिन्यूअस कास्टिंग प्रोसेस। यहाँ पर इसको पोर करते हैं, वाटर कूलिंग रहता है, as well as there is a electromagnetic stirrer also to get the homogeneity of the material throughout the cross section। अदरवाइज क्या होगा, जो impurities होती है वो सेंटर में सेग्रीगेशन होना शुरू हो जाती है, but because of the electromagnetic stirrer you will get homogeneous structure throughout the cross section of the billet। and उसके बाद अगेन वाटर क्वेंचिंग होता है और कंटिन्यूअस फिर स्ट्रेटनिंग के बाद में बिलेट्स बनते जाते हैं, एंड देन देयर इज अ कटिंग थ्रू दी टॉर्च, है ना, ऑनलाइन कटिंग करते रहते हैं, देयर आर वर्कर्स, और ऑटोमेटिक प्रोसेस भी होता है। पर्टिकुलर लेंथ के बाद द ऑक्सी एसिटिलीन जो ये रहती है हमारी फ्लेम रहती है, उससे टॉर्च से कट करती जाती है इन द डिजायर्ड लेंथ। बहुत सारी कंपनीज दे विल बाय दिस बिलेट्स एंड देन दे विल प्रोसेस द वायर रॉड और समथिंग। Which companies they will have their integrated plants, their own integrated plants. Few companies what they will do, they will buy it from outside and then they will roll it. So with this we will try to finish the steel making chapter tomorrow, and then on Saturday nothing will be there. Saturday I will upload the assignment, try to upload the assignment on Sunday same time we will have the discussion on the, or we can say doubt clearing session. Whatever we have learned in all these 4 days 5 days of the week, we will discuss it on the Sunday. That will be a doubt clearing session, so that doubt can be related to the assignment also, or it can be related to the whatever the topics we have learned so far. ठीक है, so Sunday 7 o'clock is okay. I hope everybody is okay with the 7 o'clock, because on the first day we have decided that yes, majority of the people were okay with the schedule this Saturday no session, and on Sunday there will be a doubt clearing session.
Okay.
Okay, and from Monday we will start the wire rod rolling, no, wire rod manufacturing process from the Monday. So next week almost we will finish with the wire rod rolling also, and then we can go to the core processes of wire drawing, that is pickling, heat treatment, that is parenting heat treatment, and the wire drawing. Clear? If at all we are not able to finish the steel making tomorrow, we can continue on Monday also, no issue, you know, because the wire rod rolling will not take this much time. Wire rod rolling is not that complicated, but steel making is, because steel making you are seeing there is a coke oven, in the steel making you are seeing there is a coke oven, DRI process, basic oxygen, blast furnace, electric arc, ladle refining, so many processes are there in the steel making. But in the wire rod rolling it is not that much. You have to hit the billet, send it, pass it through the rolling mill, and at the conveyor belt, that is control pull conveyor belt, you will get the wire rod. So we will end the today's session if there are no doubts. We will continue with this schedule only, having around 1 hour 10 minutes of session and 10 to 15 minutes of discussion. I think that will be more effective. That is what we have seen from last 3-4 days. Okay, so any doubts you have, people have, you can ask. No doubts? No doubts in two scenarios only. As I always say, you people have understood everything or understood nothing. But I cannot say not understood anything, because everybody was participating in the discussion also. Okay, so we will upload today's session presentation in PDF file and the video also, but video will be available tomorrow morning only. Video